And the numbers are exactly the same. The reason is the delta bar fixed class functions on G. So that's a vector space. I said you should always do counting problems by making a vector space and taking its, well, doing representation theory on the vector space. So here's a counting problem. I'll solve it by making a vector space and a representation. The delta fixed class functions have dimension. If you look at characteristic functions of conjugacy classes as a basis, it's kind of clear that the dimension is A plus B, and the minus delta bar, well, I don't know, minus delta bar fixed class functions. This space has dimension B, and well, you can compute, you can, how do I say it? Well, I've said enough. This is an exercise. This is really elementary and nice. So same numbers. The way the group elements line up and the way the representations line up. Well, we're interested in representations of this disconnected group.
David?
Yes?
What is the exercise?
The exercise is to prove that the number of delta fixed representations is equal to the number of delta fixed conjugacy classes. Yeah, anyway, but, well, so now I want to look at representations of this G delta. If I do restriction to representations of G, what happens is that an irreducible up here goes to either an irreducible or a sum of one of these two-element orbits. So either to a delta bar fixed irreducible or to a sum of a two-element orbit. And the theorem is that each delta bar fixed representation of G has exactly two extensions. Representation, I don't know, pi of G has exactly two extensions. I can't avoid writing them pi plus and pi minus, but these labels are not canonical. Two extensions, pi plus and pi minus, to G delta, and what happens is that pi minus is, well, pi minus or plus is pi plus or minus tensor with the non-trivial character of G delta over G. Z mod 2Z has this one character. So that's some representations. And so each non-fixed pi induces irreducibly to an irreducible of G delta, an irreducible pi ind.
You say non-canonical because delta is not canonical?
No, just because there's no way to pick one over the other. Remember, over here, this.
But what is the difference if I think about O2 is split into iso?
Sorry?
If I think about the splitting of the irreducible O2 representation and iso representation, it's the same scenario. If I choose my delta, I can say what is the
In that case, the operator that you need is a scalar. In general, these operators, I could have used sorry.
David?
Yes.
I have a different answer to this question.
Good.
Do O4.
Yeah.
what?
If you do O2N, we're in, go do an O2N. You do O4, for example, and if you take a highest weight A, comma 0, it has two extensions, and there's no way to call one plus, no canonical way to call one plus and the other minus.
I mean, you sort of can in that case because there's a distinguished generator, but in general.
I think a good example of it, Maya, is G is a cyclic group and G delta is
Cyclic group with twice the order. That's a very good example. Yeah. So each non-fixed pi induces to an irreducible. This is induced from G to G delta of pi, which is the same as it induced from delta of pi. And so, well, how many representations do I get altogether? I had A of these fixed representations, and so this is 2A representations. And I had B of these pairs, each of which is giving me 1, so this is B representations. So the number of representations has gone, well, this G hat has order A plus 2B, and the G delta hat has order 2A plus B. So well, that's the story. Do I want to say something about conjugacy classes? I think I won't mess with conjugacy. I mean, of course, the conjugacy classes in this extended group, there are also 2A plus B of those. Okay, so what's the story? So, how do we do this? Well, I guess I do need to say, we've talked a great deal about a parameter for a GK irreducible, and that's, you have a theta fixed carton H, you have a character, I'll just write it lambda of, well, I'll keep the bar. I'm gonna not worry about row shifts, but, and you have some new in H upper minus theta dual. So that's the story. So now I want to twist this by theta. That's how this extended group acts, and what I get is, of course, the same H, the same lambda bar, and minus nu. So the conclusion is that this GK module extends to a GK delta module. That's if and only if, well, there has to be some W in the normalizer in K of H modulo H intersection K, with the property that W nu is minus nu. And how do I say this? So what's actually true is you can choose this W so that W theta restricted to the carton is this distinguished delta. This is with respect to some positive roots making this lambda bar nu dominant. So this is just automatic if lambda bar nu, this remember is the infinitesimal character. It is regular, and well, singular infinitesimal character is always a pain, but at any rate, this is true, and so. So here's the I'll say a little bit more precise technical junk, and then some general geometric things, which were the only thing in the talk description, and then I'll quit. So here's the precise technical junk. So an extended cartan for this GK setting is, first of all, this theta stable H, and second, it's some W in this normalizer in K of H modulo, well, H upper theta. And so I want to, well, so I should write X. I mean, so X is in this extended group. This represents theta, and this W is, well, I don't know, W tilde. This is any representative of W in this normalizer in K of H divided by H intersection K, and so so I'm going to call this extended thing H delta, and this is I mean, this H delta upper theta is just generated by H upper theta and this W tilde X. So an extended parameter over this theta fixed parameter that I've got up here, this H lambda bar nu, it is an H delta upper theta module. Well, extending the one that I started with, and so it means that you have to pick an eigenvalue for this element W tilde X, and it has to be a square root of lambda bar evaluated at W tilde X squared. That's the story. This is all set up. W tilde times X quantity squared. So, I mean, there are a lot of choices for this thing, but, well, that's the story. And what makes this hard is this this sort of canonical representative delta, to the extent that this makes sense, may not be in this H delta upper theta. So your suggestion was sort of, well, you just have to choose the character by which this natural extender, it's either +1 or -1, and you're all set. But I mean, that's true on the fundamental carton. On the fundamental carton, that you do have this element delta, and Dan, were you asking? You were just rubbing your hands. Oh, okay, good. So on the fundamental carton, this delta is there, and so, you know, there's the extension where delta acts by +1 and the extension where it acts by -1, and that's great. But on the other cartons, it doesn't have to be, and so you have to use some lousy thing, and the square is some ridiculous power of I, and you have to pick a square root of that, and it's not nice. I mean, it's all possible that there's, you know, these, if you have a delta fixed thing, you can extend it. There's no problem. The problem is that you can't do it canonically. You've got these two things. Okay, so yes.
So you have two extended particles for the same initial particle?
That's what this general theorem says over here, is that each delta fixed parameter on G has exactly two extended parameters sitting over it. And they differ by this choice of square root.
Now these are all particles for the distance.
Yes, these are, yes. Well, the statement is the irreducible GK delta modules, the irreducibles for the extended group, are of two kinds. They're the ones which extend irreducibly from G, that come in pairs, and then the non-fixed pi's extend to these sort of boring things. Okay. So let me spend 10 minutes trying to say how you do computations with these extended things. So the untwisted version is, let me say, at infinitesimal character row. A parameter is the same thing as a K equivariant local system on one orbit of K on G mod B. And so, well, maybe I'll call this gamma. And so we're interested in some formulas that say J of gamma is a sum over, sorry, maybe phi is, I'm not sure. That this is a sum over psi corresponding to smaller orbits. I'll get the notation completely wrong. So something like this. These m psi phis are integers. These are standard modules. The m phi phi is 1. All sorts of things like this. The idea of Kazhdan and Lustig was the idea of Kazhdan and Lustig, which was proven by Valence and Bernstein and Brodinsky Kashiwara. Is that this m psi phi is an Euler characteristic of some of some perverse sheaf corresponding to this phi. So this perverse sheaf lives on the closure of the orbit so here's the orbit corresponding to phi, and I know I'm not allowed to use blue, but here is some boundary orbit of psi, and starting with this local system on this open orbit, you make a perverse extension. The Euler characteristic of this this perverse sheaf along this orbit for psi. So this perverse extension measures the singularity of the closure, and the coefficients of these Kazhdan-Lustig polynomials are dimensions of this sheaf cohomology. Okay. So the Valence and Bernstein localization theory relates the this localization theory relates GK modules of infinitesimal character rho to K equivariant perverse sheaves on G mod B. And this correspondence takes an irreducible to an irreducible, to what's called an intersection homology sheaf. Anyway, I'm gonna go through all of this stuff. This is what makes that theory work. Now we want to do GK delta. So, no, there's no problem. These GK delta modules correspond to K delta equivariant. The same thing. All you're doing, you have this geometric object with a K action, and this delta, well, you need to extend it to a delta action. And what happens is essentially this delta acts on these intersection cohomology sheaves, intersection homology sheaves. Up here, so yeah, I should have said these are computed by these Cauchy-Moustic polynomials P psi phi or something like that. And what's the yes, that's yes, sorry, yes, that's exactly right. So now this delta, well, what we need here, well, to get character formulas for these GK delta, what we need are the dimensions of the +1 and